welcome to my channel. Today we are going to solve LeetCode 638 shopping offers problem. So let's first read the problem statement. The problem statement is that in the store we are selling an items. We are selling an items, and we have three inputs. First one is that let's take actual example and see what are the inputs. So first we have needs. Let's say that we need first item. This is the second item. So we need three of the first item and two of the second item. So the price for them, the direct price for them is 2 and 5. So for example, if we are going to calculate how much we need to pay for our needs, then 3 multiplied by 2 is 3 multiplied by 2 plus 2 multiplied by 5 which is 16. So but besides that we also have special prices. What's that mean? Specials. What's the special means? Special means that we have a bundle. For example, for 3 of the first item and for the 0 of the second item we pay only $5. And in the second case, for one of the first item and for the 2 of the second item, we are paying $10. So the requirement is that we need to return the lowest price that we can pay for our needs. But the important requirement is we need to pay exactly certain items as given. For example, in this case, let's say that let's say that the amount here is not 3 but 4. Let's say it's 4. We cannot apply the special because the needs that we have 3 and the special has 4. So the amount for the first item is 4, so we cannot apply it. So this is the task, and these are the requirements. Let's see how we are going to solve this problem. Let's take actually the first example and work on it. So in the first example we have a price for items are 2 and 5. So our needs are 3 and 2, and also we have specials. Specials are so we have 3, 0, 5. Okay, that's the first one, and the other one is that the 1, 2 and 10. So we have the array of the specials. So these are the specials that we have. So this problem falls under the category of knapsack 0 and 1. So I'm going to make a separate video about it, but in our case what we need to do, we need to generate all possible scenarios with direct price, but also like combining the direct price and special, and we need to select the lowest price. Okay, let's generate 3 here and see that how it exactly gonna work. So for example, in our first case we are doing we are calculating just the direct price. We already calculated that, so 2 multiplied by 3 multiplied by 2, so plus 2 multiplied by 5, it's 16. So then that's the direct price that we are paying for our needs. So this is our needs, direct price that we need to pay for it. But then we try to apply each special case and see that can we lower our price. So let's apply first our first special. 3 and the 0. First of all, we need to see that can we even apply that? So because it should not exceed the needs that we have in this case. For example, in this case, we have 3 and the 2. So can we apply this? Yes, we can apply. So we are applying that. And the amount that is left that we need is 0 and 2. Because 3 minus 3 is 0. 2 minus 0 is 2. So this is the amount that we need. The amount that we need to pay for 3 and the 0 is 5. 5 plus whatever whatever amount is we can pay for 0 and the 2. For the 0 and 2, direct price is 2 multiplied by 5 is 15. So this is 15. This is already lower than 16. So, but can we make it even lower? So what we can do, we need to explore. So now our needs are not, so here when we started, our needs are 3 and the 2, but now our needs are 2, 0 and the 2. So can we make it better than that? Can we? So let's explore this option. So let's apply so we applied already direct price. So it's with the first special and direct price it's 15. Can we apply, because special we can apply unlimited number of times, right? So let's try to apply it one more time. Can we apply it? So can we apply 0, 3, 0 and 5? No, we cannot apply because this exceeds what we need, and so we are backtracking from this from the first special. Can we let's try to apply the second one. So 1, 2, so can we apply this one? No, we cannot apply because 1 is more than 0. So we are also backtracking from this solution, right? So the same way we need to explore the second. So here, for example, we are backtracking and we need to explore the second option. Second special, and to see that whatever lowest price that we get. So another problem here that this is the backtracking solution that we are applying here. So basically we are generating 3 of all possible combinations and choosing the lowest price. But the problem is here that let's say that because we may have like a lot of specials, like our needs maybe not 2 but the 100 and so and there might be case when let's say that we have another hypothetical tree that we generated here, and let's say that there is a need, let's say 5, 4, 2, and we are exploring the options. So basically we are so what we do here in our first example, right? We're actually breaking down our problem to sub-problem. Now we are solving for 0 and 2. Then we need to break down also that problem and so on and so forth. So since we cannot break down this problem, we are backtracking. So in this case, let's say that we break down this problem and we explored all the options and we get the best price for it. Let's say that the best price for this one, I don't know, 50, right? But in, let's say, another branch of the tree, let's say that in another branch, we are also trying to solve the same problem. Let's say 5, 4, and the 2. Let's say that we are again try to solve the same problem. We solve that here. We know that the lowest price, because we break down our problem and we solve that sub-problem returned us 50. So, and we already solved this problem. Once we get here and we see that, okay, 4, 5, 2. All right, we already solved this. We don't need to solve that again. So we are not explore this option anymore. So we are just gonna return whatever the value was saved for it. For that, we are gonna use dynamic problem top-down approach. So basically, once we explore our solution, we are gonna create a map where we are gonna store as a key, we are gonna store our input, which means that we're gonna store our input, which means that our needs, and as a value, so we are gonna create a map. Key will be our needs, needs, and the value is going to be the lowest price. So for example, in this case, let's say for our 0, 2, right, we are going to store this, and with the price of for 0 and 2 we can get 10, because there is no other option. We cannot use specials. So that's it. That's how we are going to solve this problem. The first approach is that we are going to use backtracking. We are going to create of 3 all possible combinations, and not to solve the same problem again. We are going to store whatever solution we have, our intermediary solution. We are going to store them in the map, apply dynamic programming top-down approach, and get those results if we try to solve the problem again. All right, let's go and see how we are going to solve this problem. Let's start and see how we're going to solve this problem. The first thing that we need to do, we need to create a method that we will call that is going to return our calculate minimum cost. Calculate minimum cost. Calculate the minimum cost. We are going to pass, it's going to take exactly the same arguments, plus we are gonna pass here hash map. So that will, as I explained already in the previous part, so we are gonna pass here list of integers plus the integer plus the minimum price that we are going to store. Let's just call it dp, and so this is our method. So let's just return here. So we are calling it calculate minimum cost, and we are passing here price, needs, and specials. So price, need, and the special. So we are passing this, and also we are passing here new hash map, so we are passing here. All right, let's see what we are gonna do. So in this method we are gonna backtrack, so that but the first thing that we need to do, if let's say that we are backtracking and our solution is already, so if in our DP we already have the needs that we have, we already checked that. So what we are going to do, we are going to check here contains key, and we are going to pass our needs. If it contains, then we are going no further. We are not exploring that solution, and we are just returning a dp get our needs. Okay, so if we are not doing that, the first thing that we are going to do, we are going to calculate direct cost. Let's just call it minimum cost, not just minimum cost, just the cost. So it's actually a cost, and let's create a method, call it calculate cost. We are passing here, so we are just calculating the direct, so we are just calculating the direct price for it, direct cost. So we are passing here our price, and we are passing here our needs, right? Let's create that method. So it's gonna return also integer, and we'll call it calculate price. We'll call it calculate price. It's gonna take needs, and price and needs. So let's remove from here special. So yeah, we are just calculating the direct cost. So let's just create cost, and what we are gonna do, we are gonna say, okay, for int I equals to 0, I less than needs size, right? And needs size, and the I plus plus. So what we need to do, we need to cost, we need to add here, we need to add to our cost whatever is needs at the moment, need get I multiplied by price get I, right? So we are just calculating the direct cost. So price get I. And then we are just returning, our cost, right? Okay, great. So far it's clear. So now let's go and explore what we are gonna do. So what we are gonna do is, we have our direct cost, but now we want to break down our problem and see that, okay, can we do better than that? So let's start to apply our specials. So for that, what we are gonna do, we are gonna take the specials. So sure, let's call it special, and we are let's just call it current. You know what, let's call it specials, and let's call it specials, and let's call this one special. So like current special. Okay, and we are passing here specials. All right. Okay, now what we are doing, the first thing that we are gonna do, we are gonna actually check that can we even apply that special or not, because as we have seen from in our explanation part and in the description, actually one of the requirement is that we need to have exact amount not exceeding our needs. So for that, we need to check that the if special. So let's create that another method. Let's call it is special applicable. Is special applicable. We are just checking that can we apply that or not. So we are gonna pass here our special, and we are gonna pass here our needs. So does special exceed our needs or not? So let's create that method. It's actually is special applicable. It's gonna private boolean is special applicable, and we are gonna check here. Okay, it takes the special and the needs, right? It will take the special and it will take the need. So what we're gonna check here, we are gonna check that. So again, we need to use the same for loop here. So it will return true by default. Now, if we pass all the checks, it will return true here. But here, what we need to do, we need to check if special get I is more than if special I more than our needs, right? Get I. So if that condition is met, then we are gonna say, all right, in that case, we are going to return false because we cannot go further. I mean that we cannot apply that special. So in that case, we are returning false. All right. So in this case, we are returning false. In this case, we are returning, I mean, if we pass all the checks we can apply, so then we are returning true. So let's go to our method. We are applying our needs, so we can apply our needs. So what we need to do for that, first thing that we need to do, we need to create a list of integer, and let's call it updated needs. Needs. So we are going to create new array list, and passing here our needs. Why we are doing that? Because we need to create a new list, otherwise it will point to the same list in the memory. So that's why we need to create our new list to pass to the method. So then we have our needs. Then what we need to do, we need to go and subtract from our needs, from our updated needs, the amount that we have in special. So let's go and do that. What we are going to do, we are going to go and I is less than needs size, and I plus plus. So what we are going to do here, we are going to, from our updated needs, we are going to set I to, we are going to set to I to needs get I, so the amount that we have at that point minus whatever special that we are applying, special get I, right? Special get I. Yeah, that's it. So for example, let's say that the first we had, if we take our example, we had 3 and the 2, right? So we are applying the first special. For the first one, we are going to subtract, it's going to be 0. And for the second item, we will need the two of those. So we are updating our needs. And after updating our needs, let's see that what is the offer cost. So our offer cost, is the offer cost is equals to special get, so special get special size. So the last element is the size of the special, the price of the special. So -1, we are getting the offer cost. So now what we need to do, we need to subtract from our main amount. We need to give me a second. So what we need to do, yeah, we have our cost. Now we need to update our cost. Yes, so we need to for our cost, we need to take the minimum cost, so so we need to take the minimum, either our cost, whatever is the minimum, right, our initial cost, or offer cost, plus so offer cost plus the whatever the minimum cost we have for the new subproblem that we have. So for that, we need to pass to call our calculate minimum cost recursively, pass here our price will stay the same, specials stay the same, our updated needs, because we have already updated our needs, and we need to pass our DP, so our dynamic programming, which means that basically our cache, and that's it. So that's it, and once we exit our loop, we can return our cost here. We can return our cost here. Let me check one more time. Okay, yeah, one more thing. Before returning our, so we explored one subproblem and already find that whatever the lowest cost for it. So that one we need to put we need to put in our map. We need to put, so needs that we have, and we needs and cost. Okay, so yeah, that's it. That's it. Let me check one more time. All right, let's run and see that okay, hash map, price special. Okay, yeah, it's a special we need to pass here. Okay. All right, great. It works as expected. And it works as expected. Let's go over our solution one more time. So what we are doing first, we are just creating another method, calculate minimum cost, and so which we are going to call iteratively. Basically, this is our method that will create all possible scenarios for us. So we are passing their price special needs, and also we are passing our hash map that we can store our results that we get, our intermediary results, not to calculate them one more time if we see the same subproblem that we solved earlier. So that's the first thing that we do. If we have in our map already, we solved that subproblem, we just return that without going further. So the next step is we are calculating the direct cost for our needs. Then we are exploring the specials. So we are taking the specials, and the first we are checking, can we even apply that special? So that should not exceed the amount that we have. So our needs should not exceed the amount that we have in special. If we can apply it, then we are updating our needs, and we are setting the values. So we are updating our needs, and we are subtracting the amount that we have in that special, right? So after that, we are taking the offer cost, and we are comparing which cost is lower, our like a direct cost or cost that we got from the offer, and plus whatever. So for example, in our case right here, we applied the first offer, and then we are solving that subproblem that is left from after applying the first special. So after applying the first special, we are now solving that subproblem. Then we will go again and solve that. We just basically breaking down problem to the very basic, to the very smallest, solving that problem, and then we are backtracking. And meanwhile, whatever, let's say that we already explored and we stored, we solved some subproblem that we are going to also solve in another branch of our tree. We are storing that in our hash map, and then if we next time we try to solve the same subproblem, we are just returning that from our map. Okay, that's it. I hope it's clear. I hope it's clear, and I hope that you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.